Pleasure to be here. This has been a great conference so far. Kenny, I appreciate everything you've done and really look forward to continued opportunities. Jason has set this up real well. I'm not going to go back and talk too much about the challenges coming forward in terms of where we're at today. You've heard that a lot of times in terms of the demand for animal protein is exploding because of what's going on globally. And we also have U.S. policies that have changed the dynamic a lot in terms of biofuels. You're all aware of that, especially here in Nebraska. Combine that with the drought scenarios, all that has led to the cost of our inputs for livestock production systems not only to be increasing, but they're now more volatile. And so it's really increased our cost, it's really increased our risk position, and so we're really faced with more challenges today than ever before. Also, society today is more concerned about how we're raising our animals and the impact on the environment. Just to give you a little perspective, more and more of our society is focused on what is the environmental impact. And we have to admit the beef cattle production systems have a greater impact than our non-ruminant livestock species, pork and poultry. CO2 equivalence basically says what's the carbon footprint of our beef cattle, pork, and poultry systems. It takes into account methane. It also takes into account nitrogen emissions and puts it on an equivalent basis, if you will. But you can see right here that beef, in terms of carbon footprint, is double, more than double that of pork. And of course, you go down the chain there, fish, chicken is even better. The point being is that more and more we're going to have to be concerned not only about how can we raise our animals to be more economically sustainable, we're going to have to think more and more about how can we make these systems more environmentally sustainable if we're going to get folks in the U.S. and globally to continue to buy our product. Now, the folks up in Canada, they now have, by law, a system whereby they trade carbon credits. And so they've put a lot more emphasis and research into what is the environmental impact of beef cattle systems. And so they are thinking more and more about technology to try to reduce the carbon footprint, if you will, for beef cattle production systems. One of the early studies was done here by John Bassard, and I want to point this out to illustrate where's this carbon coming from in terms of what does it take to produce beef. And what he concluded, and I want to point out, this is for a calf production system where calves are harvested at 11 to 14 months of age, okay? And what they concluded, if you look at the total carbon footprint, if you will, okay, the beef cow is generating 70%. And then you look at the replacement heifers, bulls, and cows, they're generating another 15%. So basically, the cow herd, if you will, is generating most of the methane and other things that go into the carbon footprint for beef cattle production systems. And it's only about 15% which is coming from the calves, from harvest or from weaning until harvest. So obviously, if we want to try to reduce the carbon footprint of beef cattle production systems, we really have to be focused on the cow because that's where the majority of that is coming from. Okay, lots of challenges. Jason kind of laid that out before. Yesterday there was some good discussion about that. In addition to thinking about how we're going to compete with the Brazilians and the Australians in terms of beef cattle production systems, we also have to obviously be concerned about pork and poultry. And so I think it's useful to sit back and look at how have they progressed. And it really is amazing how efficient the poultry industry is today and how efficient the pork industry is today. Interesting study, just draw your attention to. Haverstein, 2003, he was able to go back and get poultry broilers that were actually genetically produced in 1957 and then compare them to modern day broilers. And what he did in this study, he also fed both strains of broilers a diet that was fed back in the 50s as well as a modern type of diet. So he wanted to compare both the genetics and the current feeding program against what happened 50 years ago. What he found in a real short version is that today's broilers, okay, require 1/3 fewer days on feed and threefold less feed than they did 50 years ago. So these broilers are very efficient. They're growing faster, 1/3 fewer days on feed, a whole lot less feed. So then they asked the question, how do they make that progress? Their conclusion was that 85% of that improvement in the last 50 years was because of genetic selection. Only about 15% was due to improvements in nutrition, improvements in production. Okay? Now, the pork guys, okay? I know there's lots of pork production around this part of the country. I grew up in western Iowa on a hog farm, beef cattle farm. We used to be really happy if we got 7 pigs born and survived per sow. Okay? Now it's over 10 and a half. We always, in our farrowing, our swine operation, we farrowed twice a year. Today, it's like close to 2.3, 2.4 litters per sow per year. Some of these sows are cranking out 25 pigs a year. It's amazing how productive these guys are becoming. More pork per sow unit. But then they're also selecting for improved efficiency. And so swine guys are really improving production efficiency, feed efficiency. Well, Jason's already had a good outline of this. We all know that we've made progress in beef cattle production efficiency. But as Jason pointed out, it's mainly because we've improved the output side of things. We've done very little to improve production efficiency by reducing the inputs. One of the things that's happened, why we've become more productive, is we've selected for increased growth. This is showing genetic trend lines for Red Angus breed. Just shows that genetically our cattle are bigger, both weaning weights and yearling weights, but also our mature cow size is bigger. Okay? So we're growing more pounds of beef per cow unit, but we really haven't done a whole lot on the input side of things. Well, it's a good question to ask now. What has been the impact of selecting for growth? There's been these 5 studies here that were run anywhere from 15 to 25 years where they selected for increased growth or reduced growth or had control growth. And after the ends of these selection experiments, which take a long time, they brought the progeny into a feed yard, measured their performance, measured their intake. All 5 of these studies found that feed-to-gain ratio was not improved. And a lot of people have a hard time believing that. But what's happening is as we select for increased growth, we also indirectly select for more appetite. So feed-to-gain ratio is not changing. So Robert Herd, Australia, divergent selection for growth produced different sized animals whose ability to convert feed to gain was not altered. And really it was this experiment that then led the Australians to launch into feed efficiency research. They were the early folks that really got on the bandwagon, if you will, start looking at feed efficiency in beef cattle. And of course, with that, we've seen these trend lines. Carcass weights are getting bigger. Used to be that our top end on carcass weights were 800 pounds. We didn't want to go above 800 pounds or we'd get a discount. Now, Dr. Cross, is that 1,000 pounds? And is there really a discount if you have over 1,000 pounds? Not really. So we really don't know when we're going to get market signals to start curtailing cow size, to curtail carcass weights. But we do know that these larger cows are not working as well in terms of productivity. There's concerns about that. Well, here is the inconvenient truth about beef cattle production systems. If you look at a total energy balance, in terms of how many calories, if you will, are required for beef cattle production systems, most time you'll find out that about a third of the total calories are going to go to the slaughter progeny. So from weaning until harvest. That means that the balance of 70% is going to the cow herd. In the cow herd, roughly about 70% is going to cow maintenance requirements. So we take 70% for cow maintenance times 70% of the energy going to the cow herd. Works out that about half of the total energy is used just to support the cow to be able to live. Those calories give us no return on investment. And so that is a big part of our big reason for why beef cattle production systems are not competing as well with pork and with poultry. The cost to run the cow factory is very expensive. Well, what do we know about the maintenance energy requirement? We do know that there's breed differences. Won't spend a lot of time on this. You've seen this before. Maintenance requirements of dairy cattle are higher than Bos Indicus, with Bos Taurus breeds being in the middle. Lots of research, good research, showing these breed differences in maintenance energy requirements. These numbers are kilocalories per kilogram, 3/4 power per day. But what we often overlook is that there's a lot of variation in maintenance requirements within breeds. Just to give you a little bit of evidence for this. There's probably been about, I'd say 6 to 8 studies that have looked at maintenance requirements of individual cows within a breed type. And what we're finding is that range, this CV stands for coefficient variation, just a statistic, if you will, to show us how much variance there is within a breed. And it ranges from 10 to 30% across these studies. So there's lots of individual cow variation within a breed in maintenance energy requirements. And there's been a couple of studies to show that maintenance requirement is repeatable. You measure it one year, you measure it the next year, and you're going to see the same kind of ranking of cows in terms of high requirements versus low requirements. Also, there's been a couple of studies where we've looked at the heritability of maintenance energy requirements, and we have found them to be moderately heritable. So it would suggest that if we wanted to select for lower maintenance requirements, we could. Okay, the challenge is, how do we do that? Wanted to also put, this is another Australian study, to show you that individual cow variance in terms of maintenance energy requirements. Let me set this up. What they did here, all the cows on this trial were fed the same amount of feed per body weight, 3/4 power. They did that for about 9 months, okay, to measure the individual animal maintenance energy requirements. What this table is, our chart is showing us, is body weight gain pounds per day. And so on average, they fed these cows individually all the same amount of feed, and what they were targeting for is to be at maintenance, so they could look at the variance in maintenance energy requirements. So on average, they were at about 0, but look at the tremendous variation that they had. Okay, these cows up here, they were fed at maintenance, but gained almost 1.8 pounds per day. Okay, these cows down here, fed the same amount, actually lost weight. So it's illustrating that there's a lot of variation within a breed in terms of maintenance energy requirements. The problem we have with maintenance energy requirements is it's positively related to productivity. Okay? What I call here antagonistic with level of productivity. A breed study over here, Angus and Hereford cattle compared to Friesian cattle. Okay, this is looking at weight maintenance. This is body weight maintained per megacal of energy. A higher number means that these cows have a lower maintenance requirement. Okay? Hereford can maintain a higher weight per unit of energy compared to Friesian or Holstein cattle. Okay? When you look at that in relationship to lactation potential, you can see that there's an inverse relationship. Those cows that have been selected for increased milk have a higher maintenance requirement. It takes more energy per pound to maintain them. Okay? Also, you look at a study in Nebraska, Merlin Nielsen did this years ago. Really neat study. Came up with two groups of cows, low milk production potential. They produce 8.5 pounds or kilograms of milk versus 10.5. These were Angus Hereford cattle over here. And then on the high milk group, those cows were red poll milking shorthorn. And he went in and looked at the maintenance energy requirements during gestation, lactation, and then in the feedlot steers. What he found is that those cows that had the capability to crank out the milk had a higher maintenance requirement. During lactation, during gestation, but then also the progeny had higher maintenance requirements. So selecting for milk would increase the maintenance energy requirements in those cows. Also, what he did is all those cows, he put them on a graph here looking at maintenance requirements per amount of milk produced, showing there's a positive relationship again. So as the cows produce more and more milk, maintenance energy requirements went up. Correlation there 0.48. So it's showing that if we want to improve milk production through selection, we have to recognize that those cows are going to have a higher maintenance energy requirement. Also, other research shows that these cows that have a higher maintenance requirement, higher milk production, are also going to be less likely to breed back up if we have a drought scenario. They're less adaptable. So we got to think about how can we reduce the maintenance energy requirement of the cow herd. As Jason pointed out, one of the strategies could be to think about putting these cows into semi-confinement. NRC says requirements for maintenance associated with activity of extensive grazing can be as high as 30-40%. So if we put our cows in confinement, we're reducing the maintenance energy component. We should be more efficient. But also, can we select for lower maintenance energy requirements? The answer is yes, we could, but it's very, very difficult to measure maintenance energy requirements in cows. And plus, it would only be a single-time measurement. And so it's not feasible on a large operation to be able to look at reducing maintenance requirements through selection. Plus, again, remember that antagonistic relationship. If we were to actually select for lower maintenance requirements, we would actually see a reduction in productivity. What we really want to be able to do is to reduce maintenance requirements, but not change productivity. We need to find ways to uncouple maintenance requirements from level of productivity. That has been our challenge. Okay? Okay, going down the list here. Oops. Next one I have on here is improved reproductive performance. That kind of goes without saying. You know, if we're going to reduce the amount of maintenance requirement associated with level of output, if we can maintain output through better reproductive rates, you know, we're going to improve overall production system efficiency. You know, there's been some folks that have looked at the value of increasing the incidence of twinning. You know, if we have more of our cows producing twin calves, we would have more output. That would dilute the maintenance component of our system. We'd be more productive. So that kind of goes without saying, but there's a lot of challenges associated with that. And then also, wanted to just mention here, first calf heifer production systems. If you look at a mature cow, 85 to 90% of her total calories are going to maintenance. First calf heifer, on the other hand, it's about 65%. So a first calf heifer is actually using less total energy for maintenance requirements. So if the age of our cow herd were to become younger, we would have fewer of our calories going into maintenance requirements. But of course, that goes counter to what we always think. We want the cows to have longevity because of the extra cost of raising our first calf heifers. But down the road, it's something that I think we need to take a serious look at. I think it would dovetail nicely with semi-confinement operations. But that would be one strategy, if you will, to reduce the maintenance energy component of our system. Finally, what I'm going to focus on for the rest of the talk is, can we select for improved cow efficiency by looking at selecting post-weaning animals, either heifers or bulls. So, looking at that, we have known for a long time that if we select for feed to gain ratio, we can improve efficiency in the feedlot, okay? But we haven't really done that on an industry-wide basis. The primary constraint has always been the cost of measuring feed intake on a large scale. But now today, as you're probably aware, we've got a lot of operations that have intake equipment. We have over 100 units now that have growth-safe units in place, commercial operations to measure feed efficiency in cattle. But in the past, we've also been constrained by the fact that feed to gain ratio was not really the trait to use. Genetic correlations with feed to gain ratio, with post-weaning average daily gain a negative 0.67. Just shown here that as we get cattle that have a lower feed to gain ratio, that negative correlation means those cattle are gaining lots. Okay, so there's an inverse relationship there between feed to gain ratio and average daily gain. So in other words, if we were to select for reduced feed to gain ratio, we would indirectly be selecting for increased gain. And we really wouldn't be improving actual feed efficiency. And then also our yearling weights would get larger, mature cow weights would get larger, our cows would not necessarily be more efficient. So other ways of selecting postnatally for efficiency were evolved, and one of those is called residual feed intake. Residual feed intake is simply the actual dry matter intake of an animal, net the expected dry matter intake based on mid-test body weight and gain. Okay, what that means is you look at two animals, if they both weigh the same, they both gain the same. You would expect them to consume the same amount of feed because they should have the same requirements. But then if we actually measure their intake, what we're doing with the residual feed intake is taking the actual minus the expected. And so those animals that are eating less than expected are going to be more efficient. Now the correlations between RFI and post-weaning gain and body weight are zero, because how we calculate this trait, those two traits that it's built on are going to be independent of the intake. And so RFI as an efficiency number is going to be genetically independent of body weight and gain. Okay? But it's going to be positively related to dry matter intake. So RFI quantifies a variation in intake that is unrelated to body weight and gain. Through a lot of research, we now know it's moderately heritable and genetically independent of the growth traits. But here's the key take-home message. RFI allows us to uncouple, if you will, the genetic merit for efficiency from the genetic merit for gain. And that's the key advantage of this trait as a measure of efficiency in post-weaning animals. To kind of illustrate this further, this is some data from a bull test looking at dry matter intake plotted against average daily gain. That black line just shows the linear trend line to show that as animals are growing faster, they have a higher requirement for energy, and so they have a higher appetite, they eat more feed. Okay? So think of this as kind of like an NRC equation. But notice all the variation around that line. We have some animals up here that are eating more feed than they probably should per gain, some animals down here. We have two animals pointed out here. Bull number 818, final body weight and gain there, you can see, very close to this bull down here. This bull up here, though, ate 20.5 pounds of feed. The one on the bottom, only 16.3. If you then calculate RFI, You see here that the actual intake again on the top, 20.5, the expected intake, 18.4. So the RFI is a positive 2.2. Bull on the bottom consumes 16.3, expected intake 18.4, so it's a negative RFI. Now, how does that relate to cow efficiency? Think about RFI. We're uncoupling efficiency from genetics of growth. And that's what we want to be able to figure out with cow efficiency. How can we find those cows that have lower requirements but yet have the same level of productivity? Okay? What I want to point out here, there's lots of research to show that RFI is related to maintenance energy requirements. Okay? Things like first two studies, they actually measured heat production in animals that had low versus high RFI. Those animals with low RFI had lower heat production. We've done trials with heart rates, which is correlated with heat production. Low RFI animals have a lower heat production. Other studies showing visceral organ mass is lower. Skin surface temperature is smaller. All these things are indicating that the low RFI animals are more efficient because they have a lower maintenance energy requirement. Just to give you some perspective, a large study here with 500 animals, and showing here that low versus high RFI, basically in those 500 animals, about a third of them are low and about a third of them are high. You can see the initial body weight and gain are the same. Dry matter intake is 16% less in the lows, feed to gain ratio 16% less. See the RFI numbers, a negative 2 versus a positive 1.9 pounds per day. Okay, in this trial, all these cattle were taken to harvest, and there were small differences in carcass quality, but in essence, carcass quality, the difference in value was the same. So the real difference between these two groups of cattle came down to feed cost. See $64 or $54 savings there on the low RFI versus the high. Net revenue difference there is $64 per head. We then also looked at the economics of those cattle. Asked the question, what is the source of variation between which ones make money and which ones lose money? So all those cattle were harvested, collected all the carcass data, looked at profit per head using 3-year fixed prices. Now, Larry, you've done some of that work in Illinois. And what we found, if you look at the correlations with profit, that those animals that were more profitable, they had a lower RFI, lower dry matter intake, lower yield grade. But then they also had a higher quality grade, higher carcass weight, gained more, and had heavier initial body weight. Looking at it numerically here, the high profit steers compared to the low profit steers, 9% higher gain, 5% lower intake, 16% improved feed to gain, 2 pound per day improvement in terms of RFI, 9% heavier carcass weights, 7% lower yield grade and quality grade. We then looked at the sensitivity. What happens if we change the prices? Does that change the source of the variation that explains profit? This dotted line right here is looking at feed efficiency traits, dry matter intake and RFI. The solid line is looking at productivity traits, initial body weight, gain, and hot carcass weight. This box right here illustrates that these are the prices that we used at the time of the study. But we said, what happens if feed costs go up? What we found is then, as feed cost goes up, the amount of variation explained by the feed efficiency traits increased, whereas that explained by productivity traits decreased. The variance associated with carcass quality traits did not change across carcass price. Okay? This was at $142 base carcass price. We increased carcass base price to 172, and you can see things change a little bit. Now productivity traits are more important in terms of driving profit. But we still see that as carcass price or as feed costs go up, the variance associated with feed efficiency traits still goes up. Point being is that there's a lot of factors that influence and drive profitability in these cattle, and the variance associated with these traits changes over different price scenarios. If you are involved at all in terms of breeding Angus cattle, you probably know that feed efficiency trait they're currently using is called residual gain. So I just wanted to mention that there's another trait out there. Residual gain is simply similar to the RFI concept, but what they're doing here, they're taking actual average daily gain, net the expected average daily gain at a constant dry matter intake and body weight gain. Okay? So they're kind of flipping the RFI around. And so whereas RFI, the more negative the number, the more efficient the cattle are. With RFI, the more positive the number, the more efficient they are. They're in essence saying we want cattle that are gaining faster than we would expect based on their dry matter intake and body size. Okay? So keep in mind that with RFI, okay, very positively correlated with the average daily gain, but it's not related to body weight and intake. This is just another graph here showing the same kind of data, looking at residual gain against dry matter intake. At the same intake, these 2 points right here, we can see that there's a big difference in terms of residual gain. So the intake is the same, 9.3 on top, 9.2 on the bottom. Actual gain on the one on top is 2 versus 1.4 kilograms on the bottom. So you can see very different residual gains. That one on the top is going to be a lot more efficient. It's gaining a lot more per day relative to what you would expect. Just want to point out what some of the relationships are between these three different efficiency traits. Okay? Up on top here, feed-to-gain ratio, residual gain, RFI. Favorable phenotypes. Okay, we want to select for low feed-to-gain ratio. We want to select for high residual gain. RFI will be a low number. Okay, you can see the correlations here with average daily gain. Both of these traits are highly related to average daily gain. Favorable selection for these traits would lead to cattle that are growing faster. So you would expect higher mature body weights if you were to select for feed-to-gain ratio or residual gain. Conversely, RFI is independent of the traits. Okay, intake, you can see very little correlation there between feed-to-gain ratio, residual gain, and intake, whereas there is with residual feed intake. Finally, look at the correlation here between residual gain and feed-to-gain ratio. It's about 0.9. Okay, essentially they're the same traits, whereas the correlation here between RFI and these two traits is less, indicating that RFI is more of an efficiency trait than a growth trait like those other two are. Okay, kind of a summary at this point of the talk. All of these traits are, in fact, very valuable to try to improve efficiency. They're moderately heritable, but keep in mind that feed-to-gain ratio, residual gain are more strongly related to genetics of growth than actual efficiency. RFI is independent of the growth traits and is more favorably associated with biological mechanisms that explain maintenance energy requirements. So if we were to select then for RFI or use it in a selection index, we will hopefully find cattle that are eating less than they should based on level of productivity. But what about the cow herd? That's our focus. Can we improve cow herd efficiency, reduce the maintenance energy component if we were to select cattle based on post-weaning gain? Some evidence out of Australia where they selected for low and high RFI and Angus cattle for 2 generations. They took the progeny, put them in a feed yard, measured their feed-to-gain ratio. What they found is there's no difference in yearling weight between low and high RFI progeny from parents, no difference in average daily gain, but those progeny from the low RFI parents consumed 11% less feed and had 15% lower feed-to-gain ratio. So showing that selection in the cow herd will in fact improve feedlot efficiency of the cattle. They also did a study where they measured efficiency in Angus heifers. They actually had 750 animals in this trial. So they measured RFI in the heifers. They then put those cows all into production. They let all those heifers have 2 calf crops. After the second calf crop, they brought those cows back in as open cows, fed them the same diet. Okay? To measure is a relationship between efficiency of the heifer and efficiency of the cow. Bottom line here, looking at the correlations between RFI of the heifer and cow mature body size, negative 0.2, meaning that those heifers selected for low RFI, those cows were a little bit heavier. Okay? But a very strong correlation here with dry matter intake, meaning those cows, those females that were low RFI as heifers, also consume less feed as a mature cow. So strong evidence that there is a solid relationship between efficiency of the heifer, efficiency of the cow. But keep in mind, this study was done where the cows were open and the cows were fed the same diet as the heifers. John Bassard up in Canada did a really nice study. He had a really nice cow herd, research cow herd. He kind of did it the other way around. What he first did is he brought all the progeny into his feed yard, measured the individual feed intakes, divided the progeny into 2 groups, those that had low RFI and those that had high RFI. So the average here, ones with low, negative 1.74 pounds per day. The ones who were positive, 1.4. What he did next is he went out and he found the cows that produced those calves. And he brought those cows into the same facility, but instead of feeding them a high-grain diet like the calves were, he fed them hay only. And what he found is that the cows that produced the low RFI calves, they consumed, say, 24 pounds of hay per day on a dry matter basis. Those cows that produced the high RFI calves in the feedlot, they consumed 27 pounds of feed. So illustrating that there's a genetic component, and it's related to efficiency of the progeny. There was no difference in cow weight, and actually the cows that produced the low RFI calves actually had more back fat. Okay, so indicating that they might have had a lower maintenance requirement and were able to keep a higher level of fat cover than the inefficient cows. We did a study with Bonsmara heifers where over 2 years we measured RFI in the heifers, and then each year we would pick the 12 that were the most efficient and the 12 that were the least efficient. We had a total of 48 animals total. Those were then bred up, and then they were brought back and we measured intake again during gestation. Okay, the heifers, showing you the data here, just 24 lows and 24 highs. See the RFI difference between the 2 groups. No difference in initial body weight, no difference in gain. But there's a 17% reduction in intake, those low RFI heifers compared to the high. And of course, you can see the feed-to-gain ratio. So again, they were bred up and then brought back into the same facility. So now what we have is we have cows that are mid-gestation. See the body weights here are heavier, but there's still no difference in body weight between the low and high RFI animals. On a hay diet, the low RFI animals, 24 versus 29, as a percent of body weight, 2.14 versus 2.6. Again, strong evidence that there's a good relationship between efficiency of the post-weaning heifer and efficiency of the cow. Look at body condition score. There's no difference in body condition score of these cows all the way through the test. Big difference in bunk visit duration. Those cows that were the low RFI animals as heifers, in addition to eating less feed, they spent a lot less time at the feed bunk. They also tended to have a slower eating rate compared to the high RFI animals. We also looked at frequency of lying versus standing and step counts. No difference in physical activity between these two groups of animals. But the low RFI animals had a slower heart rate, 66 versus 71. In Florida, they did the same kind of study. This time, they had Angus Brahman cattle, measured RFI in the heifers, but then brought them back during lactation. No difference in cow weight or gain, but again, a reduction in intake of those animals that had low RFI as heifers. But again, this is during lactation. Again, no difference in back fat, no difference in milk production. So, feedlot progeny coming from animals selected for divergent RFI, yes, are more efficient. Cows with divergent RFI as heifers have similar mature body size and productivity. Favorable associations between post-weaning RFI and efficiency of forage utilization, both during pregnancy and lactation. So selection for post-weaning RFI appears to be a strategy to be able to reduce cow maintenance requirements without affecting productivity. Lastly, just a little bit of insight in terms of what's the impact on other economically relevant traits. If we were to select for low RFI, would that impact fertility? Would it impact carcass quality, et cetera? The two big studies that have been done in Canada and in Australia would suggest that there's no difference in overall pregnancy rates, calving rates, or weaning rates between those animals selected for low versus high RFI. Also in John Bessard's study, no difference in reproductive traits in those cows that produce low versus high RFI animals. There is some indication, though, that the low RFI animals were delayed in terms of having their first calf by about 5 days across these three studies. So no difference in overall pregnancy rates, but the time of their first calf was delayed by 5 days. No evidence of an interaction between year and the RFI group, and so no indication that calving interval is different. So they concluded it was probably related to age of puberty. Okay? Also in bulls, bull fertility for the most part is not impacted, but there is some slight indication low RFI animals have a lower sperm fertility, and so that needs to be further investigated. The bottom line here is that there's a slight reduction in terms of age of puberty, a slight impact on the bull fertility, but a lot of it is related to the fact that these animals are being brought into these tests. We have the animals that have earlier onset of puberty. Okay, they're going to expend more energy on sexual development. So if we adjust RFI for fat content, we see a reduction in that impact. Finally, to wrap up, the challenges. The big challenge going forward is coming up with enough intake measurement capacity. With the growth-safe systems, they work very well. Cost to measure intake is lower, but we still don't have enough of these units to meet supply to be able to measure feed efficiency in cattle. We need more accurate breeding values for intake and RFI, and we need further development on multi-trait selection index. This is just one example of an index that we've developed based on 3 traits: RFI, average daily gain, and yearling weight. Average of the index is 100. Set this up, this is RFI in kilograms per day on the y-axis, average daily gain on the x-axis. The low profit index bulls based on feedlot performance and profitability are all up here. The high profit index bulls are all on the lower right-hand side. Again, what we want are those animals that are down here. These are the animals that are above average in terms of efficiency based on RFI. They're also the ones that are gaining the fastest. So just to point out that we have these indexes that we can use to combine RFI and the growth traits. Challenges going forward, we need further development of these multi-trait indexes. We need to focus on, can we end up having indexes both for sires going to produce the progeny heifers, as well as indexes going to produce the terminal calves for the feedlot. We need further discovery validation of these genetic markers. We would hope to come up with indicator traits like feeding behavior traits that would help us to identify these more efficient animals. More research to examine further associations with other economically relevant traits. And we need to do more research looking at the impact or relationship between RFI and the heifer and efficiency of the cow on different environments, low quality, poor quality type environments. So RFI technology is a way to identify low maintenance requirement cows. To make our cow herd more efficient, we can improve efficiency not just in the feedlot sector, but in the cow-calf unit. We can also have a positive impact on the environment through reductions in manure, nitrogen, phosphorus, and reductions in greenhouse gas emissions. So lots of opportunities going forward. With that, I'll quit and take any questions now, or Russell, do you want to wait until?
Hold the question.
Okay.